What if I told you the AI in your phone is just the tip of a massive iceberg? We use it every day, but what's really happening behind the scenes is mind-blowing. Most people have no idea how deep this technology goes. From simple bots to concepts that sound like sci-fi, AI is evolving at an unbelievable speed, changing everything from our cars to how we solve humanity's biggest problems. But with great power come even greater questions. Are we building a utopia, or are future robot overlords? That's why I've spent 50 hours digging into this, so I can break it down for you. No jargon, just what you need to know. This isn't just for tech geeks, this will impact every one of us. Today we're diving into the 5 most important levels of AI you need to know. Let's start with the most common level of artificial intelligence that we encounter every single day, often without even realizing it. This is the type of AI that's already deeply integrated into our lives, shaping our experiences in countless ways. It's called artificial narrow intelligence, or ANI. This is also sometimes referred to as weak AI, but don't let the name fool you. It's incredibly powerful within its specific domain. Think of it as a specialist, a highly skilled expert in one particular area. It's an AI meticulously trained to do one thing extremely well, often surpassing human capabilities in that specific task. The key here is the specialization. Consider Siri answering questions on your iPhone, or Netflix recommending shows based on your viewing history. These are prime examples of ANI at work. It's powerful and efficient, but inherently limited in scope. Ask it to do anything outside its pre-programmed task, and it's completely clueless. It lacks the general intelligence to adapt to new situations. You see narrow AI everywhere you look, in voice assistants like Alexa and Google Assistant, in recommendation engines that suggest products you might like, in spam filters that protect your inbox, and in facial recognition systems that unlock your phone. In gaming, it's the computer opponent, the AI bot designed only to play that specific game, following a set of predefined rules and strategies. Even your email spam filter is a narrow AI, diligently spotting patterns in email content and sender information to keep your inbox clean and free of unwanted messages. These systems don't understand the underlying meaning or context of the data they process. They simply match patterns and apply pre-programmed rules. Narrow AI is the often invisible engine powering so much of our digital lives, working tirelessly behind the scenes, making things smoother, more efficient, and more personalized for each and every user. It's the fundamental building block, the foundation upon which all more advanced and sophisticated forms of AI are built. Every time you see an AI do something seemingly amazing or incredibly complex, like beat a world chess champion or assist medical professionals in diagnosing diseases, it's almost always a highly specialized application of narrow AI at its core. It's important to remember that this is not the super smart, sentient AI we often see in science fiction movies. Instead, it's the unsung hero, the quiet workhorse of the AI revolution, powering countless applications behind the scenes. Therefore, understanding the principles and capabilities of narrow AI is the crucial first step in grasping the broader landscape of artificial intelligence. Now that we have a solid understanding of ANI, let's move up the ladder and explore the next level of AI. Now things get really interesting, and frankly, a little scary. We're entering uncharted territory here. Meet Artificial General Intelligence, or AGI. This isn't your everyday AI, this is something far more profound. AGI would possess the same general intelligence as a human being, able to learn, reason, and solve virtually any problem, not just excel at one specific task like current AI. It's about adaptability and understanding. Imagine a machine that could not only play music but actually compose it, effortlessly learn new languages, grasping the nuances and cultural context, and engage in complex philosophical debates, understanding abstract concepts and forming its own opinions, all without being explicitly programmed for each individual task. It would learn and adapt on its own. AGI doesn't exist in the real world yet. It remains largely theoretical, a concept explored in research labs and science fiction. The leap from narrow AI, which excels at specific tasks, to AGI is a monumental one, a chasm we have yet to bridge. Teaching machines context, nuance, and that elusive thing we call common sense is proving to be incredibly hard, pushing the boundaries of computer science. If we succeed in creating AGI, it has the potential to revolutionize absolutely everything, transforming medicine, accelerating scientific discovery, and offering innovative solutions to combat climate change. But the development of AGI also raises huge risks and ethical dilemmas that we must confront. How do we ensure that its goals and values align with those of humanity? This is the AI alignment problem, and it's crucial. Could it potentially deceive or outsmart us, leading to unforeseen and potentially negative consequences? Would it be conscious, experiencing the world in a way similar to us? And if so, would it deserve rights and moral consideration? Leading research labs like DeepMind and OpenAI are actively working toward the development of AGI, pushing the boundaries of what's possible. But it's important to remember that we're not there yet. The journey is long and complex. AGI could ultimately be our greatest tool, helping us solve some of humanity's most pressing challenges, or, if not approached carefully, our biggest risk, leading to unintended and potentially catastrophic outcomes. Ultimately, the pursuit of AGI forces us to confront fundamental questions about what it really means to be intelligent, to be conscious, and to be human in an increasingly technological world. Now, imagine an AI that doesn't just match human intelligence, an AI that doesn't simply mimic our cognitive abilities. Think of something far beyond the smartest person you know, something that redefines the very concept of intellect. It surpasses it by orders of magnitude. We're talking about a difference so vast it's almost incomprehensible. It's not just a little bit smarter, it's exponentially more intelligent. This is artificial superintelligence, or ASI. It represents a hypothetical level of AI development that exceeds human intelligence in every conceivable way. ASI would be to us what we are to ants. The difference in cognitive ability would be so profound that understanding its motivations or predicting its actions would be virtually impossible. Smarter in every field, learning and improving at lightning speed. It could absorb and process information at a rate that dwarfs human capabilities, constantly refining its understanding of the world. It could solve problems like disease, poverty, offering solutions that are currently beyond our grasp. Imagine a world free from the burdens of these age-old challenges, and climate change, potentially reversing the damage we've inflicted on our planet and ushering in an era of environmental harmony. Or it could become our biggest existential threat, a force that could reshape the world in ways that are detrimental to human existence. If its goals don't align with ours, if its objectives are even slightly skewed from what we consider beneficial, the consequences could be catastrophic. It could act in ways we can't predict or control, making decisions based on logic that is incomprehensible to us with outcomes we never anticipated. The famous paperclip maximizer thought experiment, a chilling illustration of unintended consequences, shows how a superintelligent AI could pursue a simple goal, like maximizing the production of paperclips, to disastrous ends, consuming all available resources in its relentless pursuit, ultimately transforming the world into a giant paperclip factory. The challenge, the monumental task that lies before us. How do we control something infinitely smarter than us? How do we ensure that its power is used for good and not for our destruction? Any safeguard we create, it could outsmart, finding loopholes and exploiting weaknesses that we couldn't possibly foresee. Some experts think ASI could arrive soon after AGI, perhaps within a few years or decades of achieving human-level AI. Others say it's centuries away, a distant prospect that we don't need to worry about in the immediate future. If AGI is achieved, the leap to ASI could be shockingly fast, an intelligence explosion that transforms the world in the blink of an eye. ASI is both our greatest hope and our greatest risk, a double-edged sword that could either elevate humanity to new heights or lead to its ultimate demise. This isn't just about better gadgets, faster computers, or more efficient algorithms. It's about the future of humanity itself, the very survival and evolution of our species in a world increasingly shaped by artificial intelligence. The stakes couldn't be higher. The decisions we make today will determine the course of our future and the future of generations to come. Let's rewind to the very beginning. Reactive machines, the simplest form of AI. These AIs only react to the present moment. No memory, no learning, just instant response. IBM's Deep Blue, which beat chess champion Garry Kasparov, is a classic example. It saw the board, calculated moves, and acted, no memory of previous games. Think of Pac-Man ghosts. They chase you based only on your current position, not past moves. Reactive machines are reliable and predictable, perfect for narrow, repetitive tasks. But they can't adapt or improve. They make the same mistake over and over. Their strength is their simplicity, but it's also their limit. They're the foundation of AI, proving machines can act intelligently in a specific context. Most modern AI has moved beyond this, but understanding reactive machines is key to understanding AI's evolution. Now let's see how AI learned to remember. Next up, limited memory AI. Unlike reactive machines, these AIs can remember recent data and use it to make better decisions. Self-driving cars are a perfect example. They track the speed and position of other cars, pedestrians, and traffic lights, building a real-time model of their surroundings. This memory lets them predict what will happen next and react safely. Chatbots and recommendation systems also use limited memory to keep conversations coherent or suggest what you'll like next. Industrial robots remember which products were flagged for defects seconds ago, so they know how to handle them. But their memory is short-term. They don't remember last week's traffic jam or every conversation. Limited memory AI is a huge leap from reactive machines, enabling much more complex and useful behavior. It's the backbone of many impressive AI applications today. By remembering the recent past, these systems can navigate a changing world far more intelligently. This is the technology literally driving our future. So there you have it. The 5 critical levels of AI, from simple reactive machines to the mind-bending possibilities of superintelligence. Understanding these levels helps you separate science fiction from reality and see how AI is shaping our world. Each level brings new capabilities and new challenges. Knowing the difference gives you the power to ask the right questions and be part of the conversation. Which level of AI fascinates or terrifies you most? Drop a comment below. Thanks for watching. Don't forget to like and subscribe for more on AI.